Welcome to today's ArXiv CS Digest for May 1st, 2026. We received 504 new computer science papers today across 51 subfields. Let's dive into the top picks. Trend 1 of 5, Foundational Algorithms and Mathematical Theory. This trend explores fundamental mathematical theories and develops foundational algorithms for diverse computational and theoretical problems. This cluster covers 120 papers. Representative work includes posterior augmented flow matching, HiCOP, hybrid composition operators for interpretable learning of PDEs, and univalence without function extensionality. Trend 2 of 5, Automated Agents and Scientific Workflows. This trend explores automated agents and intelligent systems for enhancing, validating, and accelerating scientific and analytical workflows. This cluster covers 84 papers. Representative work includes Can coding agents reproduce findings in computational material science, generating statistical charts with validation-driven LLM workflows, and Run Agent, interpreting natural language plans with constraint-guided execution. Trend 3 of 5, Model Optimization and Interpretability. These papers focus on optimizing model performance, efficiency, and robustness, alongside enhancing their interpretability and understanding. This cluster covers 72 papers. Representative work includes adaptive node feature selection for graph neural networks, demystifying mergeability, interpretable properties to predict model merging success, and make your LVLM KV cache more lightweight. Trend 4 of 5, Generative Multimodal AI and Vision. This trend explores generative AI models that integrate diverse visual and non-visual modalities for advanced perception and creation. This cluster covers 112 papers. Representative work includes Custom Dancer, customized dance recommendation by text dance retrieval, persistent visual memory, sustaining perception for deep generation in LVLMs, and Let Vits Speak, generative language image pre-training. Trend 5 of 5, LLM capabilities, security, and agents. This trend explores the multifaceted nature of LLMs, focusing on their capabilities, security vulnerabilities, and defenses, and their design as intelligent agents. This cluster covers 116 papers. Representative work includes CentriGuard, a real-time multilingual defense against adversarial LLM prompts, Atlas, adaptive trading with LLM agents through dynamic prompt optimization and multi-agent coordination, and When LLMs Stop Following Steps, a diagnostic study of procedural execution in language models. Up next, our first paper out of 5, Beyond Prompt-Induced Lies, Investigating LLM Deception on Benign Prompts by Xiaomin Wu and Bingxing He from Institute of Data Science, National University of Singapore. Let's break down its key contributions. Large language models, LLMs, are widely deployed in reasoning, planning, and decision-making tasks, making their trustworthiness critical. A significant and underexplored risk is intentional deception, where an LLM deliberately fabricates or conceals information to serve a hidden objective. Existing studies typically induce deception by explicitly setting a hidden objective through prompting or fine-tuning, which may not reflect real-world human-LLM interactions. Up next, our second paper out of 5, Vulnerability Abundance, a formal proof of infinite vulnerabilities in code by Security Paradigms Workshop from NSPW 26. Let's break down its key contributions. We present a constructive proof that a single C program, the \env vulnerability factory, admits a countably infinite set of distinct, independently CV-assignable software vulnerabilities. We formalize the argument using elementary set theory, verify it against MITRE's CV numbering authority counting rules, sketch a model-checking analysis that corroborates unbounded vulnerability generation, and provide a Turing machine characterization that situates the result within classical computability theory. We then contextualize this result within the long-running debate on whether undiscovered vulnerabilities in software are \env-dense or \env-sparse, and introduce the concept of \env vulnerability abundance, a quantitative analogy to chemical elemental abundance that describes the proportional distribution of vulnerability classes across the global software corpus. Up next, our third paper out of 5, SUDP, Secret Use Delegation Protocol for Agentic Systems by Xiaoheng Yu and Ximing Zheng from Imperial College London. Let's break down its key contributions. Agentic systems increasingly act with user secrets for APIs, messaging platforms, and cloud services. Today's bearer secret interfaces implement authorization by exposure. Enabling action often means placing a reusable secret or a reusable artifact derived from it within a model steerable boundary, so a transient prompt injection or tool-side compromise becomes durable account compromise. Existing defenses cover adjacent pieces, such as secret storage, scope delegation, sender-constrained tokens, and runtime monitoring, but leave the combined agentic obligation without a common specification. An untrusted autonomous requester should be able to cause a user-authorized secret-backed operation without exposing reusable authority to the requester. Up next, our fourth paper out of 5, Unlearning What Matters. Token-level attribution for precise language model unlearning by Jiaowei Wu and Dao Zhou from National University of Singapore. Let's break down its key contributions. Machine unlearning has emerged as a critical capability for addressing privacy, safety, and regulatory concerns in large language models, LLMs. Existing methods operate at the sequence level, applying uniform updates across all tokens despite only a subset encoding the knowledge targeted for removal. This introduces gradient noise, degrades utility, and leads to suboptimal forgetting. Up next, our fifth paper out of 5. Make your LVLM KV cache more lightweight by Shihao Chun and Roger Zimmerman from National University of Singapore. Let's break down its key contributions. Key value, KV. Cache has become a de facto component of modern large vision language models, LVLMs, for inference. While it enhances decoding efficiency in large language models, LLMs, its direct adoption in LVLMs introduces substantial GPU memory overhead due to the large number of vision tokens processed during the prefill stage. To tackle this problem, we propose LightKV, a novel approach that reduces KV cache size by exploiting the redundancy among vision token embeddings. That's all for today's AR14 CS Daily. If you found this helpful, please leave a comment, and subscribe for daily paper summaries. See you tomorrow.